56. X squared plus y squared less than or equal to 16, and y less than 2 to the x. Okay. We already know that the first one is a circle, radius center at the origin, radius 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. It's a solid circle. So I'm going to graph it. This is the circle. It divides the plane into two regions, the inner and the outer. I'm checking the inner, 0, 0, that's correct. I love it. This is it. This area and points on the circle, x squared plus y squared less than or equal to 16. Now I will graph 2 to the x, but not solid. So y equals 2 to the, 2 to the x. It divides the entire plane into two regions. The region above and the region below. The origin is in the region below, 0, 0. 0 is less than 1. Yes, it is. So I am going to shade in the area below. So this area below is y less than 2 to the x, not the points on the curve. Now I have to intersect. I'm intersecting the inner area with this green area. And what do I get? This is what I get. All points on the circle, everything in between, but not points on the curve. What is this? Both at the same time. Have we gotten the idea? Do we want to look at other examples? Anyone, please? Are we okay? Are we comfortable with this, with solving systems of inequalities?
Let me try a little more.
Of course. Any preference? Maybe we want to look at something with more than one more than two inequalities. Is that something that you would like to look at?
Yeah, can we do one of those? It doesn't matter which one.
Sure. You want to choose?
Sure. Can we do 62?
Yes. 62. So we have 2x plus y less than or equal to 6, s plus y greater than 2, x between 1 and 2, and y less than 3. Perfect. Perfect pick. Okay. So we start slowly, one by one, and then we will have to shade in the whole thing. So I'm going to start with 2x plus y equals 6. When x is 0, y is 6. When y is 0, x is 3. Good. So I have the first equation. And that is 0, 6, 1, 2, 3, 4, 5, 6, and 3, 0. Stop. Equal symbol. Yes. Fine. So then it's a solid line. And this is 2x plus y equals 6. 2x plus y equals 6. Good. It divides the entire plane into two regions, to the right and to the left. I'm checking the left because I'm checking using the origin because it's the easiest. 0, 0 less than 6, yes, it's true. So we have the first area, which is 2x plus y less than or equal to 6. So this one is done. Now I continue with x plus y equals 2. X plus y equals 2. When x is 0, y is 2. When y is 0, x is 2. So 2, 0. Okay. 2 and 2. Solid? No, because there is no equal symbol. So this is x plus y equals 2. It divides the plane in two regions, above and below. It does not pass through the origin. I'm going to check the region with the origin because it's the easiest. 0, 0 greater than 2? No. No, 0 is not greater than 2, so I have to choose the opposite. So this is x plus y greater than 2. At this point, I must intersect the first two inequalities. Okay, I'm intersecting them. This and this, the intersection is here. What is this? First two inequalities. Now, x is between 1 and 2. Let's see how we represent that. X equals 1. And then both of them are solid lines. X equals 1. Here's x equals 1. And here's x equals 2. So this is between 1 and 2, intersected with the first two. So this piece here is the first three, all of them, the first three. First three. Finally, I can put in the last one. Y equals 3. Y equals 3 is a horizontal line. So somewhere here, I don't know if this will go higher than 3. So I'm going to graph it and then check. So see, my point is this. I have this area. I don't know if y equals 3 is here, or y equals 3 is here, or y equals 3 is further lower. So I'm not sure whether y equals 3 is above that piece or below or in the middle. Because this is 2, and it may be at that point or below. I don't know. We are going to check in a minute. So y equals 3? No, it's not solid. It's not a solid line. So this is y equals 3. And y less than 3 is very clear, is the below area. So when we intersect, we're left with this piece, this piece, this piece, this piece. I have to check if y equals 3 is at this corner, if it's above or below the corner. So above the corner, at the corner, or below the corner. And how I verify that is when y is 3, And when y is 3, I get x equals 1/2. So it's right in the middle. So that's correct. When y is 3, x is 1/2. So it crosses, it's not at the corner, it crosses here. So it goes to the point to, so it's this graph. Because it's right in the middle between 1 and 2. Any questions? Any questions? Anyone? This was a little bit more sophisticated in a way because the situation with y equals 3. We didn't know whether y equals 3 was above that piece that we had all three, or it was at the corner, or it was in between. It happened that it was in between, further lower than the corner. Okay. Have we gotten the idea, you think, on how to solve these systems, single inequalities and systems of inequalities? Are we okay, you think?
I think so.
Okay. I promised to go back to, if you remember, the RREF matrices. So we looked at the graphing calculator, row reduction echelon function in the graphing calculator that helped us solve matrices. Actually, use matrices to solve systems of equations. But I would like to show you one of the methods. There are two methods that we look at with the row echelon reduction. One method is called, and you will see it in your problems, in homework, Gaussian elimination with back substitution. And another method, which I consider it much easier, is Gauss-Jordan. Two mathematicians. Gauss-Jordan method of solving systems. Yes, this is with the calculator, but this will be by hand. And I would like to present this method. Why I choose this over this? It's because this one is identical with what we just did, but it's done by hand. And this one is done with the calculator. So I'm going to choose an example and show you how to do this by hand. There are operations that we can do in an augmented matrix. But let me choose a system. I'm just going back to 3x3s. And that's in that one, just to choose an example. It will look gibberish, but it's not a difficult situation. So x plus y minus z equals -2, 2x minus y plus z equals 5, and negative x plus 2y plus 2z equals 1. I'm checking x plus y minus z equals -2, 2x minus y plus z equals 5, and negative x plus 2x. So I chose problem 21 on 633. Okay. So first of all, what we know already is the augmented matrix. -2, 5, 1, and 1, 2, -1, 1, -1, 2, -1, 1, and 2. This we know from last time. That's the augmented matrix. And remember, the RREF brought the matrix, the augmented matrix, to this presentation. A, B, C, whatever numbers, 1, 0, 0, 0, 1, 0, 0, 0, 1. And I want to show you how we get from here by hand. And this is the method called Gauss-Jordan method. So if we put this in the calculator, we'll get A, B, and C in a blink. The procedure is not very short. This was very short, right, when we put it in the calculator. But it's important for you to understand the steps. Preliminaries before we start. There are 3 possible operations with the rows of a matrix. 3. 3 allowed operations with the rows. With the rows of a matrix. What are these 3 operations? I can swap rows. In other words, I can change the order of the equations. Who cares? The system will not change, the solution will not change. So similarly, I'm allowed to swap rows. If I want to put this row as the 3rd one and this one as the 1st one, the system will stay the same, the solutions will be the same. So number 1, swap rows. If needed, of course. I'm not going to do it if I don't need it. Okay. The second operation, possible, allowed, multiply or divide rows by non-zero, of course, numbers. Can I do that? We've done it all the time. If I decide to multiply this by 5, I will not change the system or the solution. If I decide to divide this by 10, yeah, I can. I will not change the solution or the system. So that's the second one. There is one more. Remember when we solved 2x2s or 3x3s, whatever, we multiplied a row by something and added to another row to eliminate. So multiply a row by a number and add the result to another row. We did that a lot to eliminate. We multiplied by -1 and then we added to another row to get a new equation. And that's exactly what it means. Okay, steps. This is very important. And we cannot ever deviate from the steps. We need to get a 1. We need to get a 1 here. That's the very first step. Then the zeros. Then we get the 1 here. And then the zeros. And then we get the 1 here, and then the zeros of the column. These are the absolute mandatory steps. We can never change direction in the middle of the process. It's always the 1 and then the corresponding zeros. It's always the 1 and then the corresponding zeros. It's always the 1 and then the corresponding zeros of the column. Okay, let's give it a shot. I only need the augmented matrix, and I want to get here. And these numbers will be the solution. X, Y, Z. We'll see what they are. I don't have them. So I'll start again. I'll copy the system. And I'm only going to use these possible operations. Nothing else is allowed. So 1, 1, 1. No. Negative 1, negative 2. 2, negative 1, 1, 5. Negative 1, 2, 2, 1. Okay. Lucky me, I already obtained the 1. It was there from the beginning. Good. So I will use this row to multiply it by a number and add the result to another row. So I will use row 1 to multiply it by negative 2 and add it to row 2 because I want a 0 here. I will also use row 1 to multiply it by 1 or not multiply it at all and add it to row 3 because I want a 0 here. So when I use a row, nothing happens to it. Notice that I cannot write the equal symbol. A matrix cannot equal another matrix. I can only write an arrow. So 1, 1, negative 1, and negative 2. Okay. 1 times negative 2 plus 2. 1 times negative 2 minus 1. Negative 1 times negative 2 plus 1. Negative 2 times negative 2 is 4. 4 plus 5 is 9. 1 times 1 minus 1. 1 times 1 plus 2. Negative 1 times 1 plus 2. Negative 2 times 1 plus 1. What have I accomplished? A lot. Done. Next step, I need a 1 here. And I'm looking at this row, and I know that I am allowed to multiply or divide a row by a non-zero number. Okay. In order to obtain a 1 here, I must divide row 2 by negative 3. I copy 1, 1, negative 1, negative 2, 0, 1, negative 1, negative 3. 3, 1, negative 1. So I have exactly what I wanted, and I also obtained the 1 in the middle of column 2. Now I want a 0 here, and I want a 0 here. Of course, I'm going to use row 2, multiply it by negative 1, and add it to row 1, and multiply by -3 and add it to row 3. One times -1 plus 1. -1 times -1 is +1 minus 1, 0. -3 times -1 is 3 minus 2 is 1. 1 times -3 plus 3, and it's 0. -1 times -3 is 3 plus 1 is 4. -3 times -3 is 9. 9 minus 1 is 8. Big accomplishment. Now I need a 1 here. No problem. I'll divide row 3 by 4. One, 0, 0, 1. 0, 0, 1, 0, 1, 2. Good. Done, 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 done. Done! Wow! I only need to get rid of this. So row 3 multiplied by 1 and added to row 2. 1, 0, 0, 0, 1, 0, 1. 0, 1, 2. 1 times 1 minus 1, 0. 2 times 1, 2, minus 3, -1. It appears that the solution is x equals 1, y equals -1, and z equals 2. Is it true? I have no clue. So where is my system? So -1, -1, -1, 2. 1, -1, 2. 1, -1, 2. 1, -1, 2. 1 minus 1 is 0, -2, -2. Correct. 2 plus 1 is 3, plus 2 is 5. Correct. 1 minus 2 is -3, plus 4 is 1. Yes. Yes, it's a long procedure. Where was my starting point? Right here. So I had 1, 2, 3, 4, 5 steps. So I have to stick with the steps. Always 1, 0, 0, 1, 0, 0, 1, 0, 0. So no matter what happens, you cannot deviate from the steps. Always 1, 0, 0, 1, 0, 0, and then 1, 0, 0. And this is it. And of course, we can check with the RREF, but there is no need. Once I have my triple, my order triple, I go back to the original problem. I would like you to practice this between now and Wednesday, and we will look at more examples on Wednesday. Any questions? Any questions?